Good morning, colleagues. Today we shall discuss the very important issue concerning the lobular hepatis. What is lobular hepatis? It is presented here, and we can say that lobular hepatis is structural and functional unit of the liver. This unit is quite small. It has a shape of hexagonal prism, and it has a size about 1 millimeters in cube. So you can imagine yourself that it's a very small particle of the organ. But in this small particle, practically all functions of the organ can be found. They are realized in this unit. We can see that in center of the lobular hepatis we can find so-named central vein. Here it is. So practically all tissue is arranged around of this central vein. I'd like to remember you that liver has a lot of functions, but most important of this number of functions are two. The formation of the bile for digestion of the food, and second is detoxication. So both of them could be realized in lobular hepatis. Let us try to draw together lobular hepatis. As I already said, lobular hepatis is arranged around these number 1 vessels, which localized in center of it, so that's why it's vena centralis. And around of vena centralis, in this hexagonal prism, there are a lot of such kind arranged hepatocytes, and they could be drawn this way. They named as trabecular hepatis. They arrange it radially, so they connects the vena centralis and periphery of the lobular hepatis. So each of them named as trabecular hepatis and or cord of hepatocytes. Between of two side-by-side arranged trabecular hepatica, we can find this of green-yellow space, which is fulfilled by the bile. So I can arrange them this way. So number 3 is ductulus biliferi. So we can say that it's biliary capillary. It's very small in size, but this bile, which is inside of the space, is result of secretion of each hepatocytes inside of trabecular hepatica. So this bile is producing inside of this space. So that's why we use another term, biliary capillary. And what is this of violet color? It's blood. So also between trabecular hepatic we can find another space which is fulfilled by the blood. It's interesting that we use the violet color, not red, not blue, but violet. Why not red? Because it isn't oxygenated blood. Why not blue as central vein? Because it isn't deoxygenated blood. So what kind of blood we can find here? This blood is mixed, arterial and venous, oxygenated and deoxygenated. So that's why we use violet color. This space, number 4, we can name as sinusoidal capillary. Sinusoidal, it means it's quite large in diameter, larger than obvious capillary bed, for example, in muscles or in the wall of the intestine. That's why we use term sinusoidal capillary. And we can see that practically each trabecular hepatica is arranged this way in all volume of the lobular hepatis. So we practically finished to draw the lobula itself. This 1 millimeters in cube small particle of the liver is drawn. Now, what about vessels? One of it, vena centralis, is in center of the lobule, but at the periphery, this is shape of hexagonal prism. So in each 6 angles of this small prism, we can find 3 vessels. Because they are 3, so we use this term portal triad. Portal triad. So we can find them here, 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 and here, practically in each angle of this small lobule. These 3 vessels we can name this way. Green is ductulus interlobularis. Practically, it isn't a vessel, it's a special bile containing duct, small duct. That's why it's written ductulus. Ductulus means small duct with small diameter. What does it mean, hepatofugal flow? It means that bile from each ductulus belliferi inside of trabecula hepatica enters to the ductulus interlobularis, and after it is this bile flows externally. It means hepatofugal direction, from center to external direction. Hepatofugal flow. And this red one vessel, it's arteriola interlobularis. Arteriola interlobularis. It serves for nourishing of each hepatocytes with oxygenated blood. That's why we use red color. So hepatopetal flow. And third is venula interlobularis. It's interesting that vena interlobularis has also hepatopetal flow. Hepatopetal means from periphery to the center of the organ, inside of the organ. Let's remember two main functions of the liver and of the most smaller units or particle of the liver, so lobules. First function is bile formation, bile secretion. And bile secretion take place inside of the space between two trabecula hepatica, two trabecula hepatis here. And then it will be flow externally, and later it shall enter the gut, exactly descending part of duodenum, and helps the digestion. So this is first function. But second function, we said, is concerned with detoxication. What is this detoxication? We have an energy in our organism due to eating. We eat food, and food provides us with energy, especially proteins of the food. But usually these proteins are foreign for our organism, and that's why they could be as a poison. They have a lot of toxins. We can remember this on the example of mushrooms. You know that there are a lot of events with intoxication which could lead to the death when the individuals eat not good mushrooms. So these proteins which are inside of foreign types of the proteins could be very poisoned. So they should be cleaned inside a special filter, and this filter is liver itself, and exactly inside of lobular hepatis we can find the process which leads to cleaning of the blood and detoxication as a process of destroying the not useful proteins or danger for our organism proteins. The blood which contains these substances, these particles, these molecules, exactly with proteins, enters the liver through vena porta, and the most small vessels, most small branches of vena porta are venula interlobularis. So each of these venula interlobularis are most small branches of portal vein. And portal vein, the blood inside of it, from where it comes to the liver? From intestine. And that's why when we digest some substances from the food, it will pass through the special veins from duodenum, from ileum, from colon, inside to the liver, and this vessel called vena porta. So vena porta serves to provide liver with blood necessary for process of filtering, and arteria hepatica provides the liver with blood necessary for oxygenation, for nourishing of hepatocytes itself. And let's try to imagine how looks the liver lobule on microscopic glass, histological glass. So these are borders of one lobule. And in the center of it, we can find number 5, vena centralis, and in each angle of hexagonal prism we can find number 1, vena interlobularis, then number 2, vena arteriola interlobularis, and number 3, here it is ductulus bilifer interlobularis. And now this rectangle I use for magnification. This space was magnified in this picture close to the main, and it is demonstration of trabecular hepatis. Here they are, and the spaces between of them are sinusoids. So number 4a, they are numerous hepatic cells, hepatocytes, and the space 4b called sinusoids. They are sinusoidal capillaries or sinusoids. This is the same. And again, number 5, this is centrally located vena centralis. And now I propose that we together draw the scheme of sinusoidal capillary, of liver lobule and surrounding structures. So we already know this picture, and now we shall try to draw together this small part of lobule, which is defined by red triangle. So we begin from centrally located part of this lobula, that means vena centralis. It's vena centralis. It is here on the upper picture, and it's here in our new picture. So number 1 is vena centralis. We can explain that vena centralis is an inflow of hepatic vein, and it takes away deoxygenated and detoxicated blood from the lobule. So that's why we said that the direction of flow is hepatofugal. And now we shall draw the sinusoidal capillary, we said, between hepatocytes, between hepatic cords, take place sinusoidal capillary. Here it is. And we used before the violet color, and again, because it's a result of mixture of red color from arteria or arteriola, which is necessary for nourishment of hepatocytes, and this blue color, which is inside of the most small vessels of portal vein. And violet color is result of this mixture of two types of blood. So let's designate number 3 is arteriola interlobularis, which is branch of hepatic artery and which brings oxygenated blood to the hepatocytes. And here number 4 is venula interlobularis, which is most small branch of portal vein and which brings blood from gut for filtering from foreign particles and molecules. And where are the hepatocytes? They are from both sides of this sinusoidal capillary, and let us draw it. Here it is from one side, and here it is from another side. So now we understand that hepatocytes are arranged around sinusoidal capillary. And we shall use this designation number 5. Number 5 is cord of hepatocytes. So here we have drawn 4 cords of hepatocytes, or trabecules of liver. Cord of hepatocytes or liver trabecules. It's interesting that between 2 adjacent cords of hepatocytes we can find this green color structure number 6. It is ductulus billiferi. So now we can understand the structure of perisinusoidal elements of the lobular hepatis. And now number 7. Number 7, what is it? It's space between sinusoidal capillary number 2 and row of hepatocytes number 5, or cord of hepatocytes. Between sinusoidal wall and hepatocytes we can find this space, very important for process of filtering, because inside of it we can find several special cells, type of cells, which fulfill the process of filtration or detoxication. So number 7 space, which is designated using this red arrow, sometimes called according to author who revealed it. We use this name perisinusoidal space of Disse, space of Disse, or perisinusoidal space. It's very important to understand this organization when we are thinking about the process of liver working, of its function. And now let's try to summarize the features of blood supply to the liver. Very important question. We can find it in our examinal cards and examinal tickets. Features of blood supply to the liver. To understand it, let's try to understand or to remember the typical microcirculatory bed which take place in muscles, in wall of the gut, in interstitial space, and so on. It's typical microcirculatory bed which is present by the terminal arteriola, here it is, and the arrow demonstrates the direction of flow to the capillary bed. And we can find an postcapillary venules which has direction in opposite side, and between them a lot of small capillaries which serves to change the gases between interstitial space and the vessels. So oxygen should be entered to the interstitial, and the carbon oxygen, this deoxygenated gases should be enter inside capillaries. And we can explain that typical microcirculatory bed has one artery which enters and one vein which exits. One artery enters, one vein exits. This is a law. This is a rule of typical microcirculatory bed. And what about the liver? What about the microcirculatory bed of the liver? So we use another color to demonstrate that it isn't usual, it isn't typical, this type of microcirculatory bed in liver, sometimes called as miraculous bed, because it is not obvious. So we can say that liver receives a blood supply from two sources. Liver receives blood supply from hepatic artery. Hepatic artery then divides several times, and most distal branch of it calls arteria interlobularis. I use number 1 to demonstrate it. And also we can find here vena, portal vein, vena portalis or portal vein, most distal branch of portal vein calls as vena interlobularis. It is a mistake here. It should be written not A but V, because it's vena interlobularis, which delivers deoxygenated blood from small intestine containing nutrients. So again we use this picture, and number 1 for demonstrate arteria interlobularis, here it is, number 1, and number 2, vena interlobularis. Again repeat that this is mistake. Vena interlobularis. It's very interesting that there is a proportion as 1 to 3. 25% of blood perfusing through liver is blood from arteria hepatica, but 35% of blood is blood from vena porta. And exactly, vena porta contains those nutrients which serves to energy in our organism. In sinusoids, it means here, sinusoids of liver lobules, arterial and venous blood mixes, and after gases exchanged, deoxygenated and detoxicated blood exits the lobule through central vein. So direction of blood flow is this, from 1 and 2 to the central vein, from arteria and vena interlobularis to the central vein. Venous deoxygenated and detoxicated blood leaves liver through 3 hepatic veins into vena cava inferior. It's very important, we should remember it. So 3 hepatic veins we can find inside of vena cava inferior. So let us summarize the features of blood supply to the liver. If we have such kind of question, what are the features of blood supply to the liver? The right answer should be that liver, in comparison with another typical microcirculatory bed, has 2 sources of blood supply. One of it is arterial sources from hepatic artery, and another source is venous from portal vein. So first feature is blood supplying from 2 different sources, hepatic artery and portal vein. And second interesting feature is so-named rete mirabile testis. Rete mirabile testis. It means miraculous network, capillary network of the liver, which is sinusoidal capillaries serving for mixing of arterial and venous blood. So these 2 different sources shall mixes the blood from them, shall mixes in sinusoid capillaries or in miraculous network. Why miraculous? Because the typical network originates from artery and finishing with the veins, and in liver it finishing both from finishing in vein, but originates both from vein and arteries. So the sinusoid is between vein and vein. This is miracle. This is unusual. So very important issue for all your future professional life, because it helps us to understand the results of using medicines, drugs, result of poisoning with any toxical substances, and so on. So please be attentive with this question. Thank you.